Right here, I'm going to show you the real-time search capability while you are writing code with Blackbox. So my question here is fine-tune Llama 3. And as you know, the Llama 3 was very recently released. So none of the models that are available in the market, whether open source or closed source, will have the knowledge cutoff after Llama 3 was released, right? But here I am just asking Blackbox.ai to fine-tune Llama 3. Let's see how it does. Yep. As you can see at the very top, here it's already finding some GitHub pages and also other blog pages where there was a fine-tuning code and entire blog for fine-tuning Llama 3. And that's what it searched first. And then it is giving me all the code. And of course, if you just click on the sources, it will immediately take you to the original blog where it fetched all the ideas and all the knowledge base from. And that's the magic of it, that you can verify your code. Now in this case it used the Onslaught library, and I actually have used Onslaught library earlier and I know this code, and so I could actually verify it right away that these are the model names under Onslaught. This is how they are using the fast language model from the library to implement a faster way to fine-tune Llama 3. But in case you are not sure, you can always go back to the sources and then check the entire thing. So this is taking me the entire raw GitHub, and you can just change the URL to see the actual GitHub pages, right? So yeah, that's just awesome. You will always have access to the latest Google search result for your queries in Blackbox. And this is the original page, that is a GitHub official page of Onslaught library, and that's the entire model and all the code which the Blackbox code referred before giving me the answer. All right, now this is one cool feature I want to show you in Blackbox. So Robo Coder, that's the window that I'm currently in. This is probably the first free complete software engineering agent that will do your agentic job completely automatically and implement the whole workflow. And it's available in Blackbox for all, that is for free users as well. But in case it's asking for adding credit or it's not working because sometimes it may be overloaded because it's kind of a premium feature, you can refer a friend to use Blackbox, and then you will get some credit to use a Robo Coder. Now let's start with it. So the first thing I'm going to ask Robo Coder to do, and as you can see, it's already telling me, hi, I am Blackbox.ai, an AI software engineer. What would you like to build with me today? So I want to build today an authorization module using React Native, Node.js, and MongoDB. It's a very common feature that you will see on almost all mobile apps. So that's what I want Blackbox.ai to build for me today. All right. Let's see. And it's actually working. You can see the status here. Agent is running task. It already gave me quite a bit of task to me. Let me increase the width. Yeah, the plan is search for the latest documentation on setting up authentication with Node.js and MongoDB, web search query, Node.js, MongoDB authentication setup documentation. That's a web search that it will do. Then subtask 2, so that was subtask 1. Then the subtask 2 is description, search for the latest documentation on setting up authentication in React Native, tool, web search, query, React Native authentication setup documentation. So it's already using the tool, web search. And subtask 3 is set up Node.js. Subtask 4 is create React Native application to interact with the Node.js server for user authentication. Exactly, the steps looks really the actual steps that you would take as a software engineer while building a React Native app. And if you can see in the terminal, it has already started working on this. So console controller and so on. Okay, let me quickly see what's happening here on the left side. Okay, after the plan, it says all done. What's next on the agenda? Let's start with subtask 1. Okay, so now it is gradually doing one subtask after another. Node.js, MongoDB authentication setup documentation. Yeah, so this is the huge documentation that it is searching. Actually, you can specify these authentication mechanism by setting up auth mechanism parameter to the value of scram SHA1. Yeah, these are all documentation detail. You can see the length of the documentation. Yeah. All right, search complete. and then it is gradually importing the required libraries. Import star as react from react.constant. Yeah, this is exactly the code that you do for setting up a React Native authentication module. And as you can see, this is already working. This terminal code is actually increasing. It is continuing its work. In the meantime, let's further see what's happening on the left. So the subtask 1 and subtask 2 was complete, and then it went to subtask 3. Let me quickly check it out. Yeah, so let's write the code to set up the Express server and connect to MongoDB in the server.js file, code for server.js. Yeah, this is the entire code for server.js. It's using the Mongoose library, body parser, as the usual suspects here. And then it is set up the MongoDB connection with mongoose.connect. Exactly, that's what it should do. And then it seems models directory does not exist. Let's create the directory first and then create user.js. So it create models directory and user.js file. And yeah, it's continuing all the individual instruction line by line it's giving me. And then great, the content has been successfully written in the models.js file. And now let's proceed with setting up the authentication routes in the server.js file. Yep, it's continuing. And then it says that the React Native project initialization is running in the background with the -y flag. Let's check the log file again to see the progress. So -y flag will just put the yes confirmation to whatever command it's running. It seems a -y flag also did not work as expected. Let's try using the yes command to automatically confirm installation. And then the React Native project installation is running in the background with the yes command. Let's check the log file again to see the progress. Check React Native initialization log. And then look at the command. It's trying to read the log file here. So you got the whole idea that this is pretty much a working software engineer for you. You can very much replace a junior software engineering job with these quite powerful agent indeed. And of course, this conversation that I'm doing, it will continue wherever you are facing any problem, any error, or something else that you don't expect. You can direct it or rechannel its effort in the right direction by just nudging it towards the right way that it should take. And of course, this was a very simple example. There are multiple of examples. There's plethora of examples that you can experiment with to be completed by your agent. For example, another one that I will probably show is just given an API token or API key for a cloud provider, how you can tell it to do your normal data science or large language model works. For example, given a text, it should get it summarized, or go to a particular URL and take all the text from there and apply chunking on the text, but that's in another example. Okay, in this video, I will show you how to use Blackbox for doing your data science agentic job. So you have a setup data set that could be Excel file, CSV file, or text file, and you want to run some data analysis job, analytics job, predictions job on them. Okay, so first thing I need to get a data set. So I went to this Kaggle data set. It's a stroke prediction data set where you have gender, age, and heart disease, etc. Various parameters which may affect or not affect the strokes. And that's your primary data. And you want to do and run various data visualization work or analysis job on this. So first thing I do is drop my CSV file into this window right here. You can, of course, directly upload it by clicking on this upload file section. And as soon as I drop, this dataset is already here, brain-dataset.csv. And the first question I want to ask the agent is this. From the attached CSV file, give me the pie chart showing the percentage of male above the age of 50 who suffered stroke. Send it. It's working, planning, and it immediately started reading the data. The CSV file filtered the data to include only male individuals above age of 50 who suffered a stroke. Calculate a percentage of these individuals, create a pie chart showing percentage of male individuals who have the age of 50 who suffered a stroke, and display the pie chart. Yeah, absolutely clean 4-step process, right? and then it imported the necessary libraries and filtered the data based on gender first. That is df gender equal to male, and df age is greater than 50. Now let me see the actual code here. Df age more than 50. And then the other part goes just well, running the code, display the picture. Yeah, fantastic. That's exactly what I wanted. That is a stroke 11.2%, no stroke 88.8%. And the output indicates that the code successfully executed and displayed. Since the task was to filter the data and create a pie chart showing the percentage of male individuals above the age of 50, we are done with the current request. Fantastic. All right, now my next question is about their BMI. So in the original data, if you see, there's a column of stroke. 1 means there is a stroke and 0 means no stroke. And there's also a column for BMI. Yeah, so I just want something like this. Now build me a histogram of no stroke versus stroke and BMI in the horizontal axis. Let's send it quite fast. Fantastic. It has already built. The stroke is this one and no stroke is this color. So the output indicates that the code successfully executed and displayed a histogram. The histogram shows the distribution of BMI for male individuals above the age of 50. Okay, so it has remembered the original question. The original question was based on this condition, male individuals above the age of 50. And it has already applied that. And after that, it has calculated this histogram. So the filter condition remains the same, which is based on my original first question. The horizontal axis represent the BMI values, while the vertical axis represent the count of individuals. Yeah, so that's exactly I wanted. Let's quickly look at the code. Yep. Filter remains df gender equal to male and df age more than 50. Stroke df, filter df, stroke equal to 1. And then no stroke is equal to 0. Yeah, exactly. It has also applied the drop NA and the beans, alpha, label, etc. just perfectly. Okay, so this was quite awesome. And of course, this is a very basic example. You can do much more exhaustive, more in-depth analysis, applying more statistical metric, for example, linear regression, XGBoost, etc. on this kind of tabular data, because the data set here was CSV file, very clean file. So it will be handled very, very easily by Blackbox, and you can do a lot more things with this. So now I'm going to use Blackbox.ai for exhaustive code commenting and inputting docstring into code. This file that I'm looking at is coming from the great repository from Andres Karpathy, the famous Nano GPT, where he is implementing from scratch the GPT architecture. And this model.py file, as you can see, this implements the neural network from very fundamental, from scratch indeed. But of course, as you can see, that these are not so much of commented. And that's what I'm going to achieve with Blackbox. So I have already git cloned this repository into my local machine. Let's go there. And here I'm back in my VS Code and looking at the same file, that is model.py. And this is the file on which I'm going to include the docstring and comment. Now, looking at this code, it's actually so many different methods and spanning 330 lines of code. So I do not want to include the docstring at once to the entire file. What I'm going to do is just select the first two classes, okay? Copying it. And now I'm going to bring up my Blackbox.ai chat. You can do it from either pressing Ctrl L or from your command palette by typing Blackbox.ai chat. Okay, and switch on the chat with your code files. And here the prompt is rewrite this block of code with proper docstring and comments. Paste those two classes here and hit enter. And it has already completed its job almost instantaneously. The inferencing speed is quite fast with Blackbox. So this is the refactored code with the proper docstring and everything. Let's just do this thing. Let's copy entire refactored code, close this part. And what I'm going to do is just select those two classes and paste my copied code, which is a refactored version. Okay. Now take a look at here, source control, which should show something if there is a change. But right now it is not showing anything because I have not saved the file. As soon as you hit Control S, then you will see that this got activated. It's showing there is one change, source control. Just click here and click on this model by file And now beautifully you can see the diff, the code diff, and on the left side the original version, on the right side the refactored version. And the refactored version, we can see all these were created by Blackbox. All the docstring with proper explanation of the arguments of the classes, and I can see those are included both in the init, forward, and also the next class, causal self-attention. And remember, these are not quite your regular frequently used classes that you see thousands and millions of examples in GitHub. These are very specialized deep learning from scratch implementation by one of the greatest engineers in this field, and Blackbox had no problem understanding them and including proper docstring into these blocks. This is quite, and also now that we have already refactored this file by including the generated docstring and comments, I am ready to commit it to the main GitHub repository. And that also you can do by generating a proper logical commit message automatically with Blackbox. So let's see how to do it. And again, very easy. Just bring up your command palette, search for AI commit message right here, and it got generated already in less than a second. And this is the commit message. It says added docstring and type hints to layer norm and causal self-attention classes and reformatted code readability. And that was exactly this refactoring was for. Remember these two classes that we refactored with Blackbox.ai. So now all you have to do is just commit here. That's all. Also, just to add, I'm using here the VS Code extension for handling your GitHub committing, GitHub pull requests, etc. There's quite a few very popular GitHub extension for that. You can just install it in VS Code, and then you will get the source control icon activated. Now let's go to see some beautiful example of auto completion of your code with Blackbox.ai. Now, first of all, make sure that you enable your Blackbox auto completion. So just go to your command palette and always enable Blackbox autocomplete. Okay. And in this case, it is just simple Python file. And what I am going to do, I will start with a comment. And based on that comment, the Blackbox will decide the next line. Let's see if it works. So my target is to connect to a SQL database. Yep. So for the first line, import SQLite, obviously, that's the very first line for connecting to a SQLite database. And the way that you accept a line suggested by Blackbox is just hit tab like this. And then it became a real line of code. And if you don't want to accept, you just press escape. That's all. And the next line, press enter again. Yeah, import pandas. I may need pandas, so I'm going to accept it again. And import numpy as MP. Yep. Again, accepting it. Import matplotlib. Yes, that's fine. Yeah, hitting enter. Okay, let's say, although it has suggested Seaborn as SNS, I'm not going to accept that. I don't need Seaborn just now, so I'm just going to escape. Now, next thing I'm going to do is database connection parameters. Hit enter. Okay, it has given me db name equal to data.db. Yeah, that's fine in one way. So they are defining each of these key and value separately. But I don't want to do that. What I want to do is define a dict. So I'm just rejecting this one. Instead, I'm going to define my db config equal to. Now let's see. Yeah, database.db. Yeah, that's one useful one. So accepting it. Press enter. Table, yeah, table, again, accepting it. User equal to user, accepting it. Password also makes sense. Host is localhost, yeah, makes sense, absolutely. Port 3308. Okay, this one, let's just, although it is one acceptable one, I'm just going to first accept and then change maybe 8080. Okay. And then press enter again. Yeah, now it's closing the curly brace. So I have already my curly brace defined here. So I'm just rejecting it. Okay, so you see that if you type your comment correctly, then that is enough for Blackbox to decide which code you want to write. And most of the time, it will give you very sensible code that you can just hit tab your way to fill up a file. And now just want to show you a little bit complex workflow and how Blackbox.ai performance measures versus ChatGPT 4o and Claude Sonnet 3.5. Now, these are the three skins. On the left, I have Blackbox.ai. In the middle, ChatGPT 4, Omni or Omni, whatever. And on the rightmost, it's a Claude 3.5 Sonnet. And this is my original prompt. Basically, the job here to compare two models, MetaLlama 3 8B Chat and Microsoft Phi 2, in terms of time to completion when I'm fetching them from Together API endpoints. So this is exactly the exact prompt I have given to all the three models. And so give me the code to run test on the Together.ai API with MetaLlama 3 8B Chat, the Microsoft Phi 2. I want you to measure 20 requests at 5 requests per second rate with output context of 16. What is each model's time to completion average, median, and percentiles distribution? And I'm also giving the entire actual working and valid Together AI API key. Now, all three of them are giving me the code that is actually running, that is actually executable, because I have tested them, all three of them. But now my whole purpose is to compare the overall functionality and overall advantages and disadvantages. First, the most important thing, look at the result from Blackbox.ai. So they are giving the various sources right here. So some of them, the model name, etc., they have taken from Hugging Face original model card. For Together AI API endpoint and related API codes that is using Python, they have taken from Together AI documentation. That's what is giving. And also they have taken something from MetaLlama 3. So all this code that Blackbox.ai has given, that can be actually checked just in case that if some of these are hallucination or not, you can always go back and check it, each part of them. And that's extremely important when you are writing code in an enterprise setup. But of course, so with the ChatGPT 4 and the Claude 3.5 Sonnet, there is no mention of source. There is no way for you to actually check that whether they are giving all these things that they are using, whether they are coming from real documentation. You pretty much, the way that you will have to do is that manually you have to Google search and go to Together API documentation and check that these endpoints actually exist. So that's one big advantage of the code that you receive from Blackbox.ai. Otherwise, in terms of the actual code content, I had a look at them. So one particular difference that I saw, that Blackbox.ai is using the statistics library instead of NumPy to calculate all these statistical metric here. That is, I want the quantiles, I want median, mode, etc. And ChatGPT 4 instead they are using NumPy directly. So NumPy is definitely a great library, of course, as you know. But the problem is NumPy is slightly heavier. Statistics is slightly lighter. Sonnet 3.5 Sonnet as well is using statistics library to calculate all those metric. And now the big thing, which is actually seeing whether the code executes within your respective browser. So yeah, I told GPT-4 Omni to execute this code, and it started first analyzing, but within probably 30 seconds or so, there was an error and it stopped in between and gave me this error that it appears that there is a network-related issue preventing the code from reaching Together.ai API endpoints. The issue typically arises due to DNS resolution failures or connectivity problems. I actually tried a couple of times, and both the times I got similar kind of errors with GPT-4o. And I told the same thing as well to Sonnet 3.5 to execute the code. Is my prompt, execute this code. And it immediately said, I apologize, but I cannot execute this code or make any API calls. As an AI language model, I don't have the ability to run code or interact with external services. Now, so that's the problem. They cannot execute it. But now coming back to Blackbox.ai, I told the same thing to it to execute it. That is, there is an icon in Blackbox.ai, right one, this one. If you just click on it, it will actually start executing the code and actually hit the external API of Together and give you the live result. And exactly that's what it did. So this is the final output after executing executing the code. So that's a great advantage when you are specifically building something which requires you to go to third-party API endpoint and get result, and you are experimenting multiple APIs, and you just don't want to go back and forth between your IDE, etc., to compare your code. This is great advantage of Blackbox.ai. You can directly execute the code within it and see the result.